Okay, so we have a projectile motion question here. You kick a football from ground level with an initial velocity of 60 meters per second at 20 degrees above the horizontal to pass to your teammate who is standing at 100 meters away from you. Find each of the following, assuming that forces from the air on the ball are negligible. What we want to find is the time the ball stays airborne, the ball's maximum height that it reaches while it's airborne, the horizontal distance it travels before hitting the ground. It also wants to know if the receiver actually receives the ball, and if not, how far and how fast is he going to displace himself to get to a position where he is actually going to receive the ball. Here I have an illustration of what's happening in this question. The green X represents the ball. The dotted green arrow and the yellow arrow represent the direction the ball will be traveling and the parabolic curve the ball will naturally make. The red X represents the receiver who is standing at 100 meters away from the position of where the ball is kicked. Now let's answer question A. Question A is asking, how long does the ball stay airborne? Now this problem is going to be a little easier for us as it provides the necessary formulas for our solutions. We have our formula for range, time, and height. Okay, so now we're just going to plug and chug. And if this is our velocity, we're going to have 2 times 60 meters per second sine of the angle over gravity. And gravity is 9.8 meters per second squared, but we're going to consider it 10 meters per second squared out of convenience. Now let's move some of these units around so that way we can better answer this question. Now algebraically, a denominator within a denominator can be considered a numerator. So that's why we're moving second squared to the position of the numerator. So really quick, we can get rid of these signs here. These units will cancel. This unit of second will cancel one of these unit of seconds. So now we have only seconds left as a unit. Now we can finally solve for t. So our answer for A is the ball stayed airborne for 4.1 seconds. Moving on to part B, we want to know what is the maximum height that the ball reached while it was airborne. So we're looking for this value, where h represents height. The given formula for height is v squared times sine 2 theta over 2g, where g is gravity. And again, gravity we're going to be considering as 10 meters per second squared. So now here I'm just going to plug and chug. This is going to equal 60 meters per second squared. And of course this is going to equal to double the angle, or double theta. And this is also going to equal to double the value for gravity here. And we're just going to move this denominator to the numerator. And these two units will completely cancel. This unit of meters will cancel one of these unit of meters. And we're going to be left with just a unit of meters. And keeping three significant figures, our answer is going to be 116 meters. So the answer for B is the maximum height that the ball reaches while it's airborne will be 116 meters. Alright, now let's move on to part C. Part C is looking for the horizontal distance or range that the ball traveled from its origin to where it will land. And the given formula for range is v squared times sine of 2 theta over g. And range is just the distance that the ball will travel horizontally. Alright, so again, we're going to plug in our variables. Now let's move some of these units around. The second square is going to move over here. And we're going to have r equal to 3600 meters squared per second squared sine 40 second squared over 10 meters. These two units of seconds will completely cancel out. This unit of meter will cancel. one of these units of meter. And all we're going to have left is a unit of meter, which is what we want because we're looking for a distance. So now we solve and get 231 meters. So our answer for C is the ball will travel 231 meters horizontally from where it was kicked to where it will land. The part D asked if the receiver receives the ball. The answer is he won't even be close to the ball because he was only 100 meters away. And then we found earlier that the ball will land 231 meters from this original point in the positive x direction. Now, in order for the receiver to actually receive the ball, we have to calculate how far away and at what speed and at what direction he will have to displace himself in order to actually receive the ball. So we know now that the ball is actually going to travel 231 meters on a positive x direction, and it will land by 4.1 seconds. So the receiver has to travel an additional 131 meters within 4.1 seconds to receive the ball. So he has to cover 131 meters within 4.1 seconds to receive the ball. He would have to be running at a speed of 32 meters per second. And he would have to be running at that speed, 131 meters towards a positive x direction in order for him to receive the ball. Now here are your answers for this question.